So for this problem, we're going to be graphing linear equations. For this particular equation, graph the linear equation y is equal to negative 3x plus 5. And I have a coordinate system here. So hopefully you have some sort of grid paper or graphing paper. It'll help make your work cleaner and easier to work with. So I'm just going to write this down. Y is equal to negative 3x plus 5. And we've seen in previous sections that we can make an xy table. And when we make the xy table, we go ahead and we plot those points and we can see the lines start to appear. So let's do that. We'll do our table here and just take a few values for x, keep them simple. How about if we do 0, 1, 2, and maybe negative 1. So then when x is 0, then y is equal to negative 3 times 0. That's 0 plus 5. So then y is equal to 5. When x is 1, y is equal to negative 3 times 1. That's negative 3 plus 5. Then y is equal to 2. Y is equal to negative 3 times 2 when x is 2. Negative 3 times 2 is negative 6 plus 5. That's negative 1. And then negative 1, y is equal to negative 3 times negative 1. That's 3 plus 5. Then this winds up being 8. So then we can go ahead and we can then plot these points. They then make these coordinates 0, 5. If this is our origin, 0, and then 1, 2, 3, 4, 5. Here is 0, 5. 1 and 2 go over 1 and up 2, 1, 2. 2 and then negative 1. 1, 2, and then down 1. Here's 2, negative 1. And then negative 1 and 8. Go back 1 and up 8. 1, 2, 3, 4, 5, 6, 7, and 8. So you can see this is where the line's going to form, right through here. However, we don't have to do all of this. We can just find the intercepts. And the intercepts are, when x is 0, what's y? The intercepts is where the line will pass through the y-axis and the x-axis. Where does it pass through the x-axis? Well, that's when y is 0. Where does it pass through the y-axis? Well, that's when x is 0. So when x is 0, it's going to pass through y at 5. So at 0, 5, and here it is right here. So all we really need to do is then find what it is when y is 0. So when y is 0, we have 0, that's y, is equal to negative 3x plus 5. So let's get rid of these other points here. Because after all, you only need 2 points to make the line. So if we can just get one more point where it goes through the x-axis here. So for solving, we'll go ahead and we'll subtract 5 from either side. We then have negative 5. That's equal to negative 3x. We can then divide either side by negative 3. So therefore, x is going to be equal to 5/3. And 5/3 is the same as 1 2/3, right? So the problem is, though, is trying to find out exactly where 1 2/3 kind of comes in over here. Here's 1, here's 2, so it's probably right around here, maybe. So then I guess you could see that the line will go right through here, similar to what we just did with our xy table. But there's another way that's more direct, and that is determining the slope and the y-intercept. That's known as the slope-intercept form, and that's how this equation is written. It's written in slope-intercept. The negative 3, that coefficient right there, is our slope, and 5 is our y-intercept. Where is our y-intercept? Well, that's when x is 0. So here it is right here. So if we get rid of this at one point, so I already have this point here. I only need one other point. So I'm going to count off the slope here of -3. Now don't forget, our slope is our rise over the run. So -3 over 1. So our run will be 1. So if I count over 1 and then down 3, over 1 and down 3, 1, 2, 3, put a point. And that's all I need, and I can make my connection that way. Or I can keep doing it. Go over 1 and down 3, 1, 2, 3. Over 1 and down 3, 1, 2, 3. Also keep in mind that this can be written as 3 over -1. That's still a slope of -3. So all we have to do is come back 1 and up 3, 1, 2, 3. But you can now see how our line is formed here. And here it is. So this graph is the graph of the line y is equal to -3x plus 5. And there we go.